Hello and Assalamualaikum. My name is Muhammad Afifi, and as you guys can see from our previous slide, this is our video assignment for the subject STA150 titled Picking Up a Marble. First and foremost, we want to express our gratitude towards our lecturer, Madam Noor Azriani, for assigning us this task and properly gave us the guidance towards completing this task. Thank you, Madam. Now, let's introduce the team members. From the top left, we have Muhammad Ikmah Hakim. Next is Muhammad Danish. Following by is Muhammad Izzul Azrin. The fourth person is me, Muhammad Afifi. And the last one is Syed Nabil Fahimi. By conducting this experiment, there are three main objectives that we want to achieve, which is number one is to observe and record the possible outcomes of picking up marbles from different colors, which is in our case is black, green, and blue. Second, to calculate the experimental probability and theoretical probability of obtaining each color of marbles. And the last one is to find the difference between experimental and theoretical probability from the experiment that we have conducted. Okay, so why this experiment is important? Firstly, we can apply the formulas of calculating probability that we have learned, and applying those increases our understanding about probability. Secondly, it gave us the chance to play with the formulas and challenge our understanding regarding the usage of those formulas. And the last but not least, we gain a better understanding of the difference between theoretical probability and also experimental probability.
Our group assignment for STA150 is experiment 3, which is picking up a marble. We put marbles in a box, and the total marble that is in the box is 30 marbles with 3 different colors. As you can see in the picture, we have 8 black, 12 green, and 10 blue marbles. The sum of all marbles are 30, which is what we needed. Here is the step-by-step guide of the method that we do to execute the experiment. First, check the box. Second step, make sure the picker's eyes are closed. Third step, the picker will pick a marble and show it to a person to record, and the person will put the marble that is chosen and put it in the box again. After doing the experiment, this is the result that we got. The number of times that we got the color black is 9. For blue, we also got 9. And for the third color, the number of times that we got it is 12. So the total frequency is 30.
Hello, my name is Izzul. Now let's move on to finding and calculation. For question A, we need to observe and record the frequency of each color for those marbles. From table 1, we can see that the total of black marble is 8, and the number of times we pick up black marble in this experiment is 9 times. The total of green marble is 12, we pick up 12 times, and lastly, the total of blue marbles is 10, we pick up 9 times. For question B, What is the experimental probability of obtaining each of the color black, green, and blue? The formula we use to calculate experimental probability is number of time event divided by total number of trials. So, experimental probability for black marble, we get 3 divided by 10. For green marble, we get 2 divided by 5. And for blue marble, we get 3 divided by 10. Question C. What is the theoretical probability of obtaining each of the color black, green, and blue? The formula we use to calculate theoretical probability is number of favorable outcome divided by total number of possible outcome. So, theoretical probability for black marble, we get 4 divided by 15. For green marble, we get 2 divided by 5. And for blue marble, we get 1 divided by 3. For question D, what is the difference between experimental probability of obtaining black marbles and the theoretical probability of obtaining black marbles? The formula we use to calculate difference between experimental probability and theoretical probability is experimental probability minus theoretical probability times 100. So, we substitute previous calculated value in the formula, which is 3 divided by 10 minus 4 divided by 15 times 100. We will get 3.33%. For question E, what is the difference between experimental probability of obtaining blue marble and the theoretical probability of obtaining blue marble? We will use the same formula like in question D. So, we substitute previous calculated value in the formula, which is 3 divided by 10 minus 1 divided by 3 times 100. We will get negative 3.33%. The negative means 3.33% below. Question F. What is the difference between experimental probability of obtaining green marble and the theoretical probability of obtaining green marble? To solve this question, we need to use the same formula from previous question. So, we substitute previous calculated value in the formula, which is 2 divided by 5 minus 2 divided by 5 times 100. We will get 0%. For question G, what is the experimental probability the selected marbles are not black marbles? We use the experimental probability of black marble, which is 3 divided by 10. We mark X is equal to marbles that are not black. So, the experimental probability of marbles that are not black is 1 minus 3 divided by 10 equal to 7 divided by 10.
Now we are moving to question 2. So the question is random variable x has probability density function given by, and this is the function that was given by the question. So the first question is calculate Ex. So Ex is the integration of x multiplied by fx dx. So we just substitute the function from the question, and then we can integrate using the range from 0 to 5. Then we just put aside 3 over 50 outside of the integral, and then we just integrate. After we integrate, we can get 3 over 50 multiplied by x to the power of 4 over 4 minus 4 over 3 x cubed plus 5 over 2 x squared with the range from 0 to 5. And then we can just execute the integration. Therefore, we can get 25 over 8. So the second question is find the cumulative distribution function of random variable x, which is fx. To find fx, we have to find the probability of x less than or equal to small x.
To find the probability, we have to integrate 3 over 50 multiplied by t square minus 4t plus 5 dt with the range of 0 to x. And then we just put the 3 over 50 outside of the integration, and then we can integrate, so we can get 3 over 50 multiplied by t cubed over 3 minus 2t square plus 5t with the range from 0 to x. And then we can execute our integration, so we can get x cubed over 50 minus 3x squared over 25 minus 3x over 10. So the third question is, using fx, find the probability of x more than 2.5. To find the probability, we have to integrate the function with the range of 2.5 until 5. So we just factor out the 3 over 50 outside of the integration. So we can get 3 over 50 multiplied by x cubed over 3 minus 2x squared plus 5x with a range of 2.5 to 5. And then we just execute the integration, so we can get the final answer, which is 11 over 16. The final question is, using fx, find the probability of x more than 1 and less than 2.5. So to find the probability, we have to integrate the function with a range of 1 to 2.5. So we just factor out the 3 over 50 outside of the integration, and then we just integrate the function, so we can get 3 over 50 x cubed over 3 minus 2x squared plus 5x with the range of 1 to 2.5. So we just execute the integration, and then we can get our final answer, which is 9 over 80.
So, for conclusion, the experiment to determine the probability of picking up marble of different colors, which is black, green, and blue, show that the experimental results are close to the expected theoretical probability. The results show that the frequency of picking up green marbles matched the theoretical probability exactly, while the frequency of picking up black and blue marbles is slightly lower than expected. The difference between the experimental and theoretical probabilities is small, with a difference of 3.33% for black and blue marbles, and no difference for green marbles. This small difference may be due to a random chance, especially since the experiment only had 30 trials only. Overall, the experiment helped us to understand how experimental probabilities can be close to, but not always equal to, theoretical probabilities, and how this difference can be explained by chance. Thank you.